Hi, today we will be talking about finding the axis of symmetry of quadratic functions written in vertex form. Here's today's FLT. Given a quadratic function in vertex form, I will be able to find the axis of symmetry. Before, we focused on finding the axis of symmetry of quadratic functions in standard form, but today let's take a look at how to find the AOS of quadratic functions written in vertex form. So the vertex form of quadratic functions is f of x equals a times x minus h quantity squared plus k. So how do we find the axis of symmetry from here? So when we are given a quadratic function written in vertex form, so f of x equals a times x minus h quantity squared plus k, the axis of symmetry, so our AOS, the axis of symmetry, is simply given by x equals h. So our h value gives us our axis of symmetry. So what would this look like? Let me draw a quick sketch. So here's a parabola, and this is our axis of symmetry. This is given by x equals h. X equals h is our vertical line for the axis of symmetry. So finding the axis of symmetry is a lot easier when you're looking at the vertex form, this form, compared to the standard form. For our first example, let's find the axis of symmetry for this function. F of x equals 2 times x minus 3 quantity squared plus 4. As usual, I'm going to write the general vertex form to see if we have an exact match. So I write f of x equals a times x minus h quantity squared plus k. We have an exact match here. It's exactly the same form, and the axis of symmetry is the line x equals h. So what is h here? H is replaced by 3, so we know that h equals 3. So our axis of symmetry, our AOS, is the line x equals 3. So again, the axis of symmetry is simply at our h value. Looking at this graph, notice that the axis of symmetry is at x equals 3. Let's find the axis of symmetry for this function. F of x equals 4 times x minus 1 quantity squared plus 2. First, let's write the general vertex form so that we can see if we have an exact match. F of x equals a times x minus h quantity squared plus k. We have an exact match, and notice how h is replaced by 1. So we know that h equals 1. And so our AOS, our axis of symmetry, is the line x equals 1. So let's take a look at a graph. Notice that our axis of symmetry is at x equals 1. On Edpuzzle, please find the axis of symmetry of this function. F of x equals 8 times x minus 2 quantity squared plus 6. What is our h value? Okay, so for our next example, let's find the axis of symmetry of the following function. F of x equals 6 times x plus 5 quantity squared plus 2. Do you notice anything different here? Let's write the general vertex form and compare. F of x equals a times x minus h quantity squared plus k. Notice we do not have an exact match, so we need to rewrite this. We will have f of x equals 6 times x minus negative 5 quantity squared plus 2. We now have an exact match, and notice how h is replaced by negative 5. So h equals negative 5. This means our axis of symmetry is at the line x equals negative 5. Looking at this graph, we know that we are correct. For example 5, we will find the axis of symmetry of the function f of x equals 2 times x plus 3 quantity squared plus 4. The general vertex form is f of x equals a times x minus h quantity squared plus k. Again, we do not have an exact match, so we need to rewrite this function. Rewriting it, we get f of x equals 2 times x minus negative 3 quantity squared plus 4. We have an exact match, and h is replaced by negative 3. H equals negative 3, so our axis of symmetry is at the line x equals negative 3. Remember, sometimes you have to rewrite the function so that it exactly matches the general vertex form. Looking at a graph, our axis of symmetry is at x equals negative 3. On Edpuzzle, please find the axis of symmetry of f of x equals 5 times x plus 8 quantity squared plus 6. Remember to rewrite the function if necessary. Here we have the function f of x equals 6x squared plus 2. What's our axis of symmetry? First, let's write the general vertex form. We have f of x equals a times x minus h quantity squared plus k. Notice here we're missing this entire h portion. What do we use to symbolize emptiness? Let's rewrite this function. We'll have f of x equals 6 times x minus 0 quantity squared plus 2. So in this case, h equals 0. H equals 0, so our axis of symmetry is at the line x equals 0. It's actually on the y-axis as we see in this graph. So this is your last example for this lesson. Please find the axis of symmetry of this function. F of x equals 2x squared plus 3. As a review, the vertex form of a quadratic function is f of x equals a times x minus h quantity squared plus k. And the axis of symmetry of a function written in vertex form is simply x equals h. Great job today, and please make sure to submit notes on Canvas.